Hi everyone, and welcome to this YouTube channel. My name is Penny, and this is Penny's Coding Bits. In this video, we're going to have a look at where we are in the advancement of AI and whether there is a need for detection of AI-generated contents. So first of all, to answer the question of where we are in the advancement of AI, let's have a look at this article that was published on Archive on April 12th, 2024. And this paper has examined 1 million papers that was submitted to archive between May 2018 and January 2024. And specifically, it has looked at the abstracts of these papers and have come up with this summary plot. And what this is a summary of the frequency of use of these terms in the abstracts of these 1 million papers before and after the introduction of ChatGPT. And in this plot, we can see that three terms have received the most notable rise since the introduction of ChatGPT, and they are language, represented by this line here, and large language models represented by LLMs here, and that is this orange line. And we can see this red line peaking up towards the end of the timeline, and this is AI. So AI, large language models, and language have seen the most notable rise in academic writing since the introduction of ChatGPT. So this is not to say that more AI generated contents have been included in academic writing since the introduction of ChatGPT. It's just saying that the academic community have been paying more attention to AI and language since the introduction of ChatGPT. So, what about the quality of this AI that we're talking about here? So, as I was writing this blog, I came across this article that had this plot, and this is comparing how fast the AI performance are catching up to human performance. So this human baseline is represented by this line here, which is constant throughout time. And all of these different benchmarks of AI performance have been catching up to this line, especially in recent years. So, this bears me asking the question of whether we need some kind of algorithm at this point to tell AI generated contents apart from human authentically written contents that we have been accustomed to traditionally. So, in terms of AI detectors, if we do a simple search on Hugging Face, which is a hub for machine learning developers, we can see that there are already a lot of tools that's open source that's developed by the developer community. And there are certainly tools designed to detect AI generated text, such as this one. So the idea with these kind of tools is that you could click on any of the example text below and you could see the probability of this text being authentically written by humans or generated by AI. So let's just click on this one, and it's giving me a result of 100% generated by AI. And this conclusion is based on the sentence length, length normality, perplexity, and length variation scores. And we can also see the perplexity of each word in this phrase. And all of these are contributing to the conclusion that this is a AI generated text. So if we go to files and go to main, now it's taking me to the back end code for this tool. And we can see that this is a lot of steps. Now, it's useful to organize this algorithm into a flowchart so that we could see what exactly is happening here. And that flowchart looks like this. So we could see that the first step is to install libraries. And we could see that there are a lot of libraries to be installed on the first line here. So I have listed what each library does in this list here. So let's just go through this one by one. The first one is transformers, and transformers provides models for natural language processing, which is important in our case because we're analyzing text. And datasets is a library that strives to provide a large collection of easy to use datasets for machine learning and natural language processing. So machine learning and natural language processing are models that needs to be trained on datasets that represents a class. So in our case, the class is either human written or AI generated. So once the model is trained based on these data sets, it can tell whether a data set is falling into one category or not. And next one is Gradio, and Gradio is enabling the easy creation of web interfaces for Python functions. So that gives rise to the user where you could pick the example text to be used in the text box, and you could press on the submit button and you could see all of the analysis in a visually appealing format. So that's what Gradio is enabling the tool to do in this case. And the next one is Torch, and this is a library for deep learning. And the next one is a commonly used machine learning library called scikit-learn. And the next one is NLTK. And NLTK stands for Natural Language Toolkit. And this is for working with human language data. And the last one is IPython widgets. And this is widgets for Jupyter notebooks. So that is all of the libraries that are used in this tool. And once the libraries are installed, we need to load the dataset. And the dataset is from the GPT Wiki intro data, which is located at this location right here. And this data set contains the wiki intro column, which represents how introductions would look like if they are written by humans, and the generated intro column, which contains how introductions would look like if they are generated by AI. And we have these two columns for each of the Wikipedia topics that are listed here. So with this data set loaded, we need to process the data to only include what we need. And we only need the wiki intro and generated intro columns, and we only need the first 10,000 rows of data. So once we have the data processed, we need to define a tokenizer. And what we are using in this case is the GPT-2 model as well as its associated tokenizer. And for those of you who are not familiar with GPT-2 model, you could go to my past blog post on creating poetry with AI, and it goes into more detail on the GPT-2 model here. So once we have the tokenizer defined, we would use the tokenizer to tokenize the human and GPT generated texts in this chunk right here through these for loops. At the end of the tokenizing exercise, you could see that a data variable is created by appending a bunch of statistics together. So let's just have a look at each of these. The first one is NLL, which stands for negative log likelihood loss. which measures the difference between the predicted probability of classes of a data point and its true class. And if you want to dig into this a bit more, you could go to my previous blog post on cross entropy loss, which is another way of saying negative log likelihood loss. And in this blog post, I have used this simplified equation for a cross entropy loss to calculate categorical cross entropy loss. And next, we have the mean sentence length as well as the standard deviation of the sentence length. And here we also have the Shapiro-Wilk test's p-value, which checks for normality of sentence length. And in the code chunk that follows, you could see that these statistics are plotted here so that they can be visualized. So once we have the statistics visualized, we can use them to predict whether a piece of text is humanly written or generated by AI. And we are doing this by using the logistic regression model as well as a simple feed-forward neural network model. So once the logistic regression model and the neural network models are trained, they need to be saved so that they could be called back later to make predictions on newly provided text. And this is where write binary comes in. So this piece of code writes the Python object for the logistic regression model contained in the lr_model file in binary form in the model.pickle file, and the same with its associated data, so that later it could be called back and converted to Python object through the read binary command for use for predictions. So once we have the models trained and saved, we need to come to the specifics of what we are basing our decision of determining whether a piece of text is human written or generated by AI. And a part of that decision rests with the perplexity score, which we have defined our function to calculate here. And this measures how often uncommon words appear in the text. And another part of the decision rests with the negative log likelihood loss, as well as the mean sentence length and the standard deviation of the sentence length, as well as how the sentence length fits into the normal distribution. So once we have these two functions defined, we could apply them to a piece of AI generated text. And this is how the scores look like. And the developers have also applied the metrics other than the perplexity score to two more pieces of human written text. And they all had these outputs right here. And once we have the logics done, we are down to the user interface design. And you could see that the metrics are being called in here by test text and perplexity. And they are all being applied to this text variable. And we also have this sample text that we have seen on the tool itself. And here we have the actual definition of the user interface design. And you could see the inputs where you could type in or use any of the example text, where you could submit your text to analyze, and the outputs that contains the metrics used to analyze whether this text is human written or generated by AI. And we also have the launch command with the debug equal to true in case we are running into errors. And at the end of the code for the tool, we also have this little code chunk here that divides a paragraph into sentences for easy processing. So this is all for this tool. I hope you'll find this useful and insightful for looking into the back end of a AI content detector. I'll see you in the next video.